Hi there! Welcome to our Cloud and DevOps full course by Simplilearn. Are you looking to kickstart a career that's both exciting and in high demand? Welcome to Simplilearn's Cloud Computing and DevOps full course. In today's tech-driven world, cloud computing and DevOps are the powerful digital transformation for businesses everywhere. Companies are rapidly shifting to the cloud to scale their operations, and with DevOps, they are streaming their software development processes more faster, more efficient. This course is designed for anyone, from beginners to those looking to deepen their knowledge. We'll start with the fundamentals, giving you a solid foundation in cloud computing, where you will explore how platforms like AWS, Azure, Google Cloud are revolutionizing businesses. Then we'll dive into the real world of DevOps, showing you how it bridges the gap between development and operations, ensuring faster, more reliable software releases. You'll also learn about cloud architecture, security, and how to design scalable hands-on experience with tools like Kubernetes and Docker for containerization and Jenkins for automating your CI/CD pipelines. We'll also cover automation and monitoring tools that ensure your systems are always running smoothly. And by the end of this course, you will have the skills to manage cloud infrastructures, implement DevOps practices, and build scalable, secure systems that businesses rely on. So if you're ready to dive into the future of tech, let's get started. Also, guys, if you're looking to future-proof your tech career, this professional certificate program in cloud computing and DevOps by E&I Academy IIT Guwahati is the perfect choice for you. In just 8 months, you will gain hands-on expertise across AWS, Azure, Google Cloud, master DevOps tools like Jenkins, Docker, Kubernetes, and work on 30+ real-world projects. What makes this program stand out? Well, you get official Azure certification, IIT Guwahati issued credentials, access to live masterclasses, and even campus immersion opportunity. Plus, with AI-powered job assistant, resume building, and interview preparation, you are set up for real career growth. So whether you are upskilling or making a career switch, this program offers everything you need to know to thrive in the world of DevOps space with IIT Guwahati-backed credibility and practical learning that actually sticks. So what are you waiting for? Hurry up and enroll now, and you can find the course link below.
Hello everyone, welcome back to the channel. Today, I want to take you on a journey that could transform your career, much like how cloud computing has transformed some of the world's most innovative companies. Imagine Netflix, once a DVD rental service, transforming into a streaming giant capable of delivering high-definition content to millions of users simultaneously. Or consider Airbnb, which has used cloud computing to manage listings and bookings for millions of properties around the globe, providing a seamless experience for hosts and travelers alike. Both Netflix and Airbnb utilized cloud technologies to efficiently scale their businesses, manage large volumes of data, and ensure high availability and performance. So by transitioning from traditional costly and inflexible on-premises infrastructure to scalable cloud environments, they significantly reduced cost, accelerated innovation, and improved user experience in real time. Now you might think that working on such impactful projects requires years of experience and advanced degrees. But there's the good news, guys. With the right approach, you can start a career in cloud engineering in just 3 months, even if you are starting from scratch. In this video, I will outline a clear, actionable plan that uses entirely free online resources to get you there. We will cover the essential skills you need to learn, the certifications that can help validate your knowledge, and practical projects that will make your resumes stand out. So if you're ready to dive into the world of cloud computing and perhaps one day contribute to the next big thing in tech, so stay tuned, guys. So let's get started, and the number one point you should start with is starting your cloud journey. So transitioning into cloud engineering may seem daunting, especially if you are new to this field. The first step is understanding why this is a valuable career move. The cloud industry is booming with a projected market value of $800 billion by 2025 and the potential to grow even further. This growth means a constant demand for skilled professionals, making it an excellent time to enter the field. Now that we understand the industry's potential, the next question is, where should you start? So you should choose a cloud provider. So choosing a cloud provider is a critical decision as it shapes your learning path and future jobs opportunities. So the 3 major players are AWS, Azure, and Google Cloud Platform, GCP. So starting with AWS, so AWS, that is Amazon Web Services, is often recommended for beginners because it has the largest market share and a wide range of services, which translates into more job opportunities. Now coming to Azure, that is another strong option, especially if you're targeting jobs in enterprises that use Microsoft technologies. Now coming to GCP, that is Google Cloud Platform, and it is gaining popularity and offers excellent features, especially in data analytics and machine learning. For beginners, AWS is popular choice due to its widespread use and extensive documentation. However, it's important to research the demand in your local job market and consider your own interest when making a decision. And with the cloud provider chosen, the next step is to build a strong foundation in the fundamental technologies that underpin cloud computing. So now, before diving into cloud-specific services, it's essential to understand the foundational technologies that cloud computing relies on. These include, number one comes networking. So understanding how data moves across networks is crucial for setting up and managing cloud infrastructure. Then comes operating systems. Familiarity with operating systems, particularly Linux, is essential as most cloud environments run on Linux servers. Then comes virtualization. So this is the process of creating virtual instances of physical hardware. That's a core concept in cloud computing. And then comes databases. So knowledge of databases, both relational and non-relational, is critical for managing data in the cloud. So with these foundational skills in place, you are now ready to explore cloud-specific learning paths. So let's start with certifications. So certifications can validate your knowledge and make you stand out in the job market. For AWS, starting with the AWS Cloud Practitioner certification is advisable. This certification provides a broad overview of cloud concepts and AWS services. It covers key areas such as compute services, storage options, security measures, networking capabilities, and billing and pricing structures. Now coming back, while certifications are valuable, they need to be complemented with practical, hands-on experience to truly demonstrate your skills. Here comes building projects or hands-on practice. So building projects is the most effective way to apply what you have learned and to demonstrate your abilities to potential employers. So here are a few beginner-friendly projects to consider. Number one is setting up virtual machines. So start by launching an EC2 instance on AWS. Learn about the different instance types, configurations, and the basics of server management. Then comes the next project, that is cloud storage systems. So experiment with services like S3 for object storage and RDS for relational databases. Document the use cases and differences between these services. Then deploy a web application. Host a static website using S3 and CloudFront, which will teach you about web hosting, content delivery, and the basics of DNS management with Route 53. Initially, you can use the AWS console for these tasks, but as you progress, try implementing these projects using infrastructure as code tools like Terraform. This approach not only deepens your understanding, but also aligns with industry best practices. In addition to practical projects, having some coding knowledge can greatly enhance your capabilities as a cloud engineer. So now we'll see how you can learn to code. While not always mandatory, coding skills can significantly enhance your effectiveness as a cloud engineer. Languages like Python and Bash are particularly useful for scripting and automation. Even a basic understanding can help with tasks such as writing scripts for server automation, managing cloud services or resources programmatically, then implementing infrastructure as code. For those new to coding, check out Simplilearn videos on YouTube, which offers excellent starting points. Coding skills not only make you more versatile, but also open up opportunities to specialize in areas like DevOps or cloud native development. And once you have built your skills and some projects, it's time to start with the job hunting process. That is, building your profile. Creating a strong online presence is crucial when job hunting. Your LinkedIn profile should clearly reflect your new skills, certifications, and projects. So here are some tips. Number one is optimize your LinkedIn profile. That is, include a professional photo, an engaging summary, and detailed description of your projects. Then comes network actively. Connect with professionals in the field, join cloud computing groups, and participate in discussions. And then comes apply strategically. Tailor your resume for each job application, highlighting the skills and projects that align with the job description. Applying for jobs can be a number game, so be persistent. It's also helpful to reach out to recruiters or hiring managers directly to express your interest in the role. As you start to gain experience in your first cloud role, consider specializing in a niche area to advance your career. And then comes specializing and continuous learning. So specializing in a particular area of cloud computing can make you more valuable and increase your earning potential. Possible specializations include DevOps, that is, it focuses on automation, continuous integration, and continuous deployment practices. Then comes serverless computing, work with functions as a service, that is FaaS, and other serverless architectures. And then comes security, specialize in cloud security to protect data and infrastructure. The cloud industry is dynamic with new tools and technologies emerging regularly. So continuous learning is key, so stay updated through online courses, webinars, and industry news. Finally, remember that the journey into cloud engineering is continuous and ever evolving. So if we talk about resources, so embarking on a career in cloud engineering is challenging but highly rewarding. Utilize free resources like YouTube tutorials, community forums, and documentation to guide your learning.
Today, we're going to go through a complete end-to-end journey on what it takes to set up a DevOps team. We're going to go through what we need to be able to do to go to DevOps, what the arguments are and why you need to do DevOps. And then we'll actually go through all the individual tools you need to be able to successfully implement DevOps within your organization. In addition to that, we're also going to take time and go through each of those tools so you get a good understanding of a step-by-step instructions on how to do basic setup of each of those tools. So let's get started. So what was DevOps before? So what was the process that we took for doing delivery before DevOps? Well, it was a model called waterfall, and waterfall was a very traditional approach to actually building out solutions. And the reason why it's called waterfall is that you break out all the individual requirements and individual sections of a project and they cascade off each other. So if we look at the breakdown, we have requirements design, we have implementation, we have verification, we have maintenance, you'll have user acceptance testing. This is all based on the software development lifecycle model, or SDLC. And it's been around for quite some time and is still used by a lot of companies today. The challenge you had with the waterfall model is that it really is a very long, drawn out model for actually building and delivering solutions. So it took a very long time to actually write code and then deploy the code. It was very difficult to actually identify problems within the code and provide feedback to the development team on what to fix. And this really was a very time consuming. We're talking about months, sometimes years, for projects to actually go through a waterfall model process. So along came a new method of being able to do delivery, and it's called Agile. And the Agile approach is a way of being able to take the actual work that's done in a waterfall model and compress it down into small iterations. And what we would do is a fundamental change is that you would actually take teams that were disparate and as part of the individual cascades within a waterfall project, and you actually bring them together. So you have your requirements team person, a design, developer, and release management team all together in one group working on an iteration. The great thing about Agile is that you took a process that was weeks or months or even years in length, as it was with Waterfall, and you reduce it down to 2 or 4 week sprints, depending on the cadence for your team. Typically, you have a 2-week sprint, and then the goal is that at the end of each sprint, or sometimes every other sprint, you would do a software release, and so that customers were getting the software much faster. The problem that we still ran into, though, with Agile is fundamentally similar to what we were having with Waterfall. You have your DevOps person working on code on their system, and it'd be working great on their computer, and then you have the operations person who's migrating the code from the developer's environment, the test environment, to the production environment, and you would run into issues where the code simply wasn't working. And there's a lot of reasons why that would happen. The actual developer environment would often be very different or would have different dependencies in it. So the hardware, the software, there may be additional applications that were installed on the operating system that simply hadn't been transferred over to the operations environment. And so what you would have is a disconnect between the developer environment and the operations environment, making it difficult to actually roll out code. So you'd run into a program where when you rolled out code, you'd have to have a rollback fallback plan in case the code wouldn't work in production. And so each release became an event where everybody got very stressed about the actual event of releasing code because you didn't know whether it was going to work. So DevOps really looks to address and solve a lot of these problems. So the key word that you'll often hear with DevOps is continuous integration. And what that means is essentially that as a developer is working on their code, the code is constantly being tested against not just the actual code itself with unit testing, but the environment with which it's going to be released in. And the goal from a DevOps model is that the breakdown of communication that happens with waterfall and agile, where developers and operations teams aren't working in the same environment, is being removed, and you're able to provide a continuous and contiguous environment between the developer and the actual operating model. So the reality is, when the developer is working on their code, they're actually working in an environment that is identical to the production environment. And so when the actual operations person comes to actually do releases for the code, and you can see some teams are doing as many as 20 to even up to 50 releases to production environments every single day, you're able to guarantee that the actual code itself will work, and releases go from being a stressful event to a byproduct of good testing and good setup and structure for how you actually build out your solutions. So what we're seeing here, so the goal is that as a developer and as an operations person, that the code is working continuously in both environments. You have continuous integration and continuous delivery. So simply put, what we're able to do is we're able to eliminate the problem of the operation environment not being in sync with the development environment. And this is an improvement on Agile. And this is not to say that Waterfall or Agile are wrong as delivery models. What it is just a maturity of the ability to deliver solutions. And DevOps is just another rung in that maturity curve, using tools that are available to us now that 5-10 years ago simply weren't available. So the goal is for you as a team to move to a DevOps model where you can implement continuous releases on your software as long as you're using the tools that are available. And the good news is those tools are open source tools. So let's go through some of the benefits of why you'd want to go and use DevOps. So, essentially, what's in it for you? So over the next few slides, we're going to go through what is DevOps. We're going to go through the benefits of DevOps. So in the last few slides, you've actually seen, what is DevOps and the benefits of DevOps along with the life cycle. But we're also going to start digging into the tools that you have that are useful for DevOps. And we're going to focus in on 7 tools that can provide an end-to-end infrastructure for delivering DevOps solutions. There are significantly more tools available on the market, but these are 7 of the most popular for each of their categories. So DevOps really is an essential collaboration between the development team and the operations team. These are teams that have in past been somewhat at conflict with each other, and what you have now is an opportunity where those teams can now work continuously with each other. The expectation with DevOps is that it will continue to mature. Indeed, you're actually even seeing some groups which are now called DevSecOps, where they're integrating security as part of the delivery between the development team and the operations team. The bottom line is a DevOps engineer is highly in demand. The demand for a DevOps engineer is literally going through the roof, with salaries going up exponentially around that. So let's dig into some of the benefits of DevOps. It's not just a new catchphrase, it's actually got significant value and how you can speed up delivery of your software. So the benefits of DevOps can really be broken up into a number of key areas. First of all, we have continuous delivery of software, which allows you to continuously release new features with the security and understanding that the software going out is of high quality. It allows the teams that are working on the software delivery within your organization to more effectively collaborate with each other so that you're all talking from the same page and understanding of what needs to be delivered. The deployment process itself moves from being an event where there's a lot of stress and there's a lot of contingency plans to being a much easier deployment. environment. The efficiency within the actual code that you're writing and the ability to scale up using the different tools that are available allows you to be able to bring in and scale up and reduce the teams you have running the software as needed. Errors can be fixed much earlier and more quickly and can be caught before anything gets pushed out to the production environment. And fundamentally, what we're looking for is improving the security of the actual releases. So the actual concept of security is center to all the work you're doing. And then finally, what really allows you to reduce the number of errors is that there is much less manual intervention. There is a greater reliance on scripted environments that you can actually test and validate for their security, reliability, and uptime efficiency. So let's talk a little bit about the life cycle of a DevOps. So the very first step that you'll take is to actually build out a build and test environment. And this is a continuous build and test environment. And this is managed with the first step of your source code. Once you move through that, then you're looking at continuous integration, which means that every time somebody checks in their code, they're validating that the code actually can run in the production environment. Once you've actually then passed the continuous integration and the testing that you have with your code, you're looking at continuous deployment. If the code works and is available to be released into the production environment, let's go ahead and release it. And once you actually have release code, then you want to be able to validate that your environment is working efficiently. You may release code that is a new feature within your application, and customers may then gravitate immediately to that new feature. If they do, you want to be able to ensure that the code is working, and more importantly, that the infrastructure is there to support. And then finally, you're looking at software released as a continuous event. And then you go back to the beginning. You start working on more code. You run it through your build environment and continuous integration, deployment, continuous monitoring, and keep that cycle moving. So let's dig into the tools that you as a DevOps engineer would need to learn. If we break down the environment that we have, all the way from source code management to software release, there are a number of key tools that you want to be able to use. So for instance, source code management, Git is an open source tool that you would want to use for managing your code. The continuous build and test environment will be managed with Maven and Selenium. Integration with the environments that you're working on is managed through Jenkins. The actual deployment to your production environments would be managed with products such as Ansible and Docker. And then the monitoring of your network would be used with tools like Nagios. The thing that you have to remember with all these tools is that they're open source tools. There is no licensing that you have to purchase. Some of the tools will have pro level licensing that you can choose to select. But to get started, all of these are open source tools you can actually start using for free right now. So let's dig into Git. So let's look at the challenge that Git is able to address. So before Git, and if you had a team of developers that were working on different pieces of code, one of the key problems you have is that there was no collaboration between the team. And the challenge you have is that with version control, it was difficult and often required having to check in to large environments, or you had very quasi version control environments. It was time consuming. Often there were problems that what would happen if the version control server would crash and there wasn't a backup, then you'd have to kind of essentially go back to square zero to see whether or not you actually had to do the work again. So let's look at what Git does to actually solve this. So first of all, one of the things that Git does is it makes team collaboration much easier. The software itself is more effectively documented and more effectively maintained. The actual code that actually gets worked on by each developer in a Git environment is the complete code. So it makes it much easier for backups and for sharing content amongst each developer. So the way in which Git is able to accomplish this is that it is essentially a distributed version control solution. And what that means is that when you have multiple developers, yes, you do have a Git remote hub that you connect and are able to upload and download different branches of the code that you're working on. But essentially, as a developer, when you actually have the code, you actually have all of the code, and you're able to manage it directly from your local PC or your local development machine without having to worry too much about the network or the server actually going down. So some of the key things in which Git is really good at, it is a software management tool. It's designed from the ground up to manage code development. It does track the changes on that code easily and effectively. It makes it easy for you as a developer to track your code. The ability for multiple developers to work together is much easier in comparison to other solutions. And this is really the key success point with Git, is that it allows for non-linear code development. So you can actually have people working on different areas of the code that may be released at different times because of what they're working on. So if we actually break down the architecture of Git, it really falls into 4 key areas of a working directory, a local staging area, a local repository, and a remote repository. So the process you would go through is you would add files to the staging area from your working directory, and this would be usually the git add command. And then from your staging area, when you're ready to actually then commit those files to a local repository, you would use the git commit command. And then from there, you would actually then push your local repository out to the remote repository for a final commit to the remote repository. And this allows then the rest of the team to pull down your latest final changes. So you can be working on your code locally, and you can be using your local staging area, local repository, and when you're ready to commit your work, you can commit it. And then as soon as it's committed, the rest of the team can then pull down the latest changes that you have worked on. And this allows for a complete and holistic checkout and check-in process. And then sometimes you want to be able to go through and then take the checked out code that you're pulling out and merge it with your local code. And the merge process always ensures that you are working on the latest and best version of the code, and everybody on the team is being consistent with the communication of the actual code that's being delivered. Okay, so what we're going to do is we're going to validate that we have Git running on our computer. We're going to then create a directory, add a file to that directory, make some changes to that file, and then use the commit commands to be able to check in the files and validate changes that have been made. So first thing we do is we're going to see if we have Git installed, and to do that you just use the command git version and git -- version, and they'll actually then give you the version number. And now we're going to create a new folder, so mkdir green, and that'll create a new folder, and we'll move our cursor into the green folder by changing the directory. And we can go back into Windows and we can validate that that directory is actually there. So here we go. Let's have a look. We should see it. There's the green folder. If I double click into that, you'll see there's nothing in the folder right now. So what we have to do is we actually have to add the folder as part of a Git project. And so we're going to use our git init, and they'll actually initialize the folder and make it a Git repository. And so let's go ahead and create a file that'll actually go inside of that new initialized folder. And you'll see that there's a .git folder that's been added. So the new text file we're going to create is going to be called class, and it'll actually be class.txt. The extension is hidden by default. In the text file, we're just going to type in the text, welcome to Simplilearn, and save that. Now let's go ahead and check the status of that file in Git. So let's do git status, and you'll see that it says yes, there's a file there, but it hasn't been committed to the repository. That's why it's in red. So what we have to do now is commit the file to the repository, and it won't be able to track any changes that we do to that file. So let's go ahead and commit the file. So we do commit add class.txt, and they'll add that to the repository, and there we are, it's added. And the final step is we want to do is commit it. And let's do git. So let's do git commit -m, but in this will be our first commit, and this is the description. And so it actually shows us committing the file. It's the only item in the folder. So now we can go over to the file that we just created, and we can make some changes to it. So let's open up the file. So it says, welcome to Simplilearn. Let's put in some text afterwards that says, this is my demo. And we'll save that, close that. And now if we go back to Git, we can do a compare and contrast between the original file that we committed and the new updates that we've just done. And we can check the difference by using git diff, and what you'll see is the red text was the original text, and the green text is now the new text that's been added. And so that shows you how you can actually go and create a new Git repository, go through adding files, committing the files into the repository, and being able to see the different version controls. Let's move on to Maven. So why use Maven? So why use Maven? Well, let's look at some of the things that you would have done in the past if you were actually building out the tasks. So let's break down what you would have done before using Maven if you were to create a game of football using Java. You would actually have to go out, and for your actual game, you'd have to collect all of the different components needed within the Java environment to make sure that everything would work correctly. And if you made the slightest mistake, you wouldn't get the right output that you needed. The actual process of building and deploying a project really would take quite a lot of time. After Maven allows you to be able to take templates that are stored locally and be able to use those to be able to improve the efficiency of being able to build out your environment by removing dependencies within the application. It makes it a lot easier for you to be able to focus on just writing the code for your game or your solution rather than having to manage the environment within which that solution would be deployed. Now, the focus within Maven is that it is an automation tool and it's used for projects that have a short period of time. So as you're starting on your environment for building out solutions, Maven is great to get started with. And then if you need to have longer term projects, then you can look at other alternative tools on the market. So 4 key areas that you want to focus on and why Maven can help you is that it does allow for efficient parallel builds to be run concurrently. It's really easy to use. You can get up and started with Maven very quickly. You do have fast access to new features and new configurations quickly within your environment, and the build process that will allow you to be able to visualize your code happens very quickly. The actual architecture of Maven is that the execution and commands are managed through what's known as a POM file. The POM file itself is a project object model, and it's an XML file that actually has the details for the project and the configuration for the build environment. POM file itself will then fetch dependencies from the local repository and will apply any plugins that you may have also included within your Maven environment. The goal is that your software is built in a much more controlled manner. So what we're going to do now is we're going to show you how to go through and run your very first project using Maven. The first steps you're going to have to do is make sure that you have the latest JDK installed on your computer. So we're going to go ahead and open up our web browser and get this installed on your computer. So we're going to type in JDK download into our Chrome web browser and go to the Oracle website, which allows us to download the JDK. And because we're running this on Windows, we're going to download the Windows version of the JDK. And once you have that installed, so the next step is to actually then go ahead and download the Maven files. So it's going to take us to the mavenapache.org website, where you can actually go ahead and download the version of Maven that you need for your operating system. We're going to go ahead and download the zip file instead of just an executable file. Now this will give you more control over how you install it onto your Windows PC. After the file has been downloaded, we want to go ahead and extract the entire file so you have the unzipped folder running on your computer. So one of the things that we're going to have to do is go through and set a number of system variables for the JDK and for the path to your Maven files. And to do that, you want to go into your control panel and select the system security and then system settings, and then go into advanced system settings. This will give you access to the edit system variable setting that you're looking for. So we're going to go down to the path variable, and you'll see already that we have pasted in the link to the JDK right there underneath the variable value. If you've installed the JDK, it's likely that it's already installed this path for you correctly. The good news is it's actually fairly easy to install the path to Maven and to the JDK, because all you have to do is copy the path for where the folder is located on your system and just paste it into a variable value under the edit systems variable file system. And that should now get us all of the files. And we can see that we have our extracted folder already on our desktop there. And the system path is now set to where the Maven folder is located. So we also have to go into system protection and set the system path to your Maven folder. Now we have to go ahead and do a user variable that also links to the path of the Maven files. So what we're doing right now is we're just validating that all the files have been extracted correctly. They have, which is good. We can now go ahead and link to these Maven folder. All right, so now what we're going to do is we're going to move over to command prompt. And this is where we're going to do most of our work from here on out. First command we're going to do is mv. So we're going to go ahead and create a new user variable, and we're going to type in, we're going to call this one m2 dash, and then we'll put in the path to the Apache Maven folder. You should be able to use m2 dash home for your project, but if it's not, you can always use the variable name Maven dash home, and that will do exactly the same as m2. We're going to do both here just so we have a backup. So we're going to open up command prompt and we're going to see if Maven is installed. We do that by writing mvn -- version. And here we are, yes. So now we're going to go ahead and create our first Maven project. And the first part of creating the Maven project is actually the directory in which we will store the files that will be used to create for our project. So we're just going to go ahead into the folder and we're going to create a new directory, and we're going to call this one, and we're going to call it Simplilearn. And we can just copy the path for that. So I'm going to write the correct path for us. So we're going to change directory, cd, and copy the file location over. All right, we are now moved ourselves over to the Simplilearn folder, and we'll be able to install the POM file, which is what all the instructions from Maven are stored in, into this area. So to do that, we're actually going to use a template that's already been created by Maven, and this is going to be the mvn archetype template. And so you just do mvn archetype : generate, and this will go ahead and create all the files for us. So there can be quite a few files, and they're all being downloaded from the Maven website. So it can take some time, but as you see, we've gone ahead and all the files have downloaded, and we have everything up and running correctly inside of our environment on command line and command prompt. So we'll have some values that we do have to set. The first one is group ID, and we're going to call this one com.mav. And then the next one is going to be artifact ID, and this is going to be mav -- project. Hit return, and then version is going to be 1.0 - snapshot. We'll just put in the same value for this version, which will be 1.0 - snapshot. And the package, we're going to call this one com.mav.demo. And then we'll select yes or Y to create the environment, and it will build the environment for us. And what we have now is we have this screen which shows everything is up and running for us. And we have a successful build. So let's go into the Maven folder and just see that we have our Simplilearn folder. Let's open it up and see what's in there. So we double click into that directory. Yep, and there we are, starting to see some of our files. So it's the same project names there as mav - project. And then we have our POM file that's in there, which is fantastic. Under the source folder, we'll actually see the demo, and we have our app under the demo app. We have our test file as well. So in the main folder, we have a file that's called the POM file, and that really is the most important file that you need for your project. You'll now go in, you'll be able to set all your settings inside of that POM file. But that's it. That's what we have done here. Is we've gone through all the setup that allows you to make sure you have the right files running on your computer, the right files to download from the Maven website, how to install all of the files, the settings you need to make on your Windows computer, and then all the settings that need to be done in the command line to be able to run the application. And then from here, you can actually start running Maven. Now let's look at Selenium as we get started looking at testing. So before Selenium, if you wanted to run testing, and particularly if you want to do sequential testing, it would take up a lot of time. You'd have to run one test, then a second test, and then all of the other tests, and the actual time elapsed would be quite significant. With Selenium, you're actually able to do parallel testing. So instead of looking at the amount of time it would take to actually run a test and run the test sequentially, the length of time to actually run your test is based on the length of the longest running test, of which in this example, the longest running test is 2 minutes. Now, one of the things that you'll notice with Selenium is that its focus is on web applications, and it is an open source tool, and it's really good at regression and functional testing of web applications. If you're doing a mobile application or if you're doing an IoT application, there are other tools you can use on the market as well. But if you are new to DevOps and you're setting up your first DevOps environment, Selenium is a great place to start, and web applications are mature and allow you to be able to test out and validate the concept of continuous testing in your environment. So 4 key takeaways for Selenium. It really is fast. Fast execution, it's highly accurate, so you can always validate that what you're doing will work correctly, and feedback can be sent straight back to the developer if their code doesn't pass the test. It allows you to script in multiple languages. Again, this is a great way for you to test. The focus is on web applications, but you can test in multiple languages used for web applications, and most importantly, allows for parallel test execution, which speeds up the whole test process significantly. If we're actually to break down the architecture of Selenium, what you'll find is the actual libraries that you can use for Selenium run in C#, Java, Python, JavaScript, PHP. These are the common languages used to build out web applications. The actual web driver itself is an API driver, which is fantastic because it makes it easier for you to integrate Selenium with applications through API. And you can run the solution through different web browsers, the most popular being Firefox, Chrome, and Edge. So to focus, the Selenium WebDriver codes are being used to build out the client libraries that make it to allow you to be able to build solutions across multiple web application environments. The WebDriver application interface is used to integrate with the application to make it easy for testing. The WebDriver service provides an immutable stateless environment that makes it very easy for you to be able to use protocols such as JSON to wire up your test environment. The driver manages the communication between the browsers and the wire protocol that's used for JSON within the web browser itself, and then the actual commands are then run through the web browser for you to be able to get your results. Okay, so before we actually get into the setup of Selenium, the first things we want to do is we want to make sure that we have the right version of Java installed. And so I'm just using the command window here, and I'm going to type in Java, and actually what I can see now is I do have Java installed, which is fantastic. Otherwise, you'd have to go and download Java from Oracle's website. The next step is to validate that I have Eclipse installed, and I'm just typing Eclipse, and there we are. I have the Eclipse app installed. You can actually download Eclipse from the Eclipse website. The third step I want to check is to validate that I have a browser driver installed. So I'm using Google's Chrome for my main browser, but you can actually go out and download the Chromium driver, and that's the actual core engine that powers Chrome. Interesting enough, being used in the new Microsoft Edge web browser. So you can actually go and download the latest Chromium driver and install that. And then the final stage is to go to the Selenium website and download the jar files themselves. So just do a Google search on Selenium download, and here we have the seleniumhq.org website, and it takes us straight to the download page. And we want to download the latest version, and we've gone ahead and done that already. So we have everything running, and now the next step is for us to install all of this great content. Okay, so before we actually get into the setup of Selenium, the first things we want to do is we want to make sure that we have the right version of Java installed. And so I'm just using the command window here, and I'm going to type in Java, and actually what I can see now is I do have Java installed, which is fantastic. Otherwise, you'd have to go and download Java from Oracle's website. The next step is to validate that I have Eclipse installed, and I'm just typing Eclipse, and there we are. I have the Eclipse app installed. You can actually download Eclipse from the Eclipse website. The third step I want to check is to validate that I have a browser driver installed. So I'm using Google's Chrome for my main browser, but you can actually go out and download the Chromium driver, and that's the actual core engine that powers Chrome. Interesting enough, being used in the new Microsoft Edge web browser. So you can actually go and download the latest Chromium driver and install that. And then the final stage is to go to the Selenium website and download the jar files themselves. So just do a Google search on Selenium download. And here we have the seleniumhq.org website, and it takes us straight to the download page. And we want to download the latest version. And we've gone ahead and done that already, so we have everything running, and now the next step is for us to install all of this great content. So we're just going to go ahead and open up the Eclipse environment, and it always takes a moment to launch Eclipse. And we're going to go ahead and create a new project, and we're going to call our project XYZ. I think that should be fine, and this is just a test after all. And we're going to go ahead and create a new class file by right-clicking and select New Class. And we're going to go in here and we're going to give the class file a name of Simplilearn. And I don't see the Finish button being selected, so maybe we need to select some other options here. Oh, you know, I think it could be the package name. Yeah, let me go ahead and change the package name, and I'm going to change that to QWE. Yep, and the finish button has now been highlighted. I can select that. I can go select that and select finish. And we now have a test page that's up and running, but what we have to do is to validate that Selenium is actually part of the project. So to do that, we're going to go to the source, to the actual source XYZ file, and right click on it. And we want to validate that all the files are there correctly. And so we're going to see that we have the libraries are there. Yep, there's Selenium. If it's not there, you can select Add External Files and find the Selenium jar file, select Open, and that would load that in there. And then you hit Apply and Close, and that would then apply it to your project. And now we can actually start writing the code part. So we're going to put this code in the public static void section. And the first command is going to be a system.setProperty, and we want to make sure that we're configuring the WebDriver for Chromium correctly. So we're going to do WebDriver .Chrome driver, and then the argument is actually going to be the full network path to the Chromium driver that you have on your PC. So let's see, we have Chromium here. We want to copy that path. And so paste that in. And then after we've pasted in the path, we have to make sure that we also put a link to the actual file that we want to execute, which in this case is chromedriver.exe. And then we want to make sure that the WebDriver is pointing to the new Chrome driver. And you'll notice that there's a couple of red colors on here, which means that we don't have all of the public classes imported correctly. So you can right-click on that and select Import the WebDriver and just select that real quick, and that adds the import correctly at the top of the page. And the same for Chrome driver. And that's just a very quick way when you're working in Eclipse to import additional files. So before we actually start our test, we want to make sure that we've actually cleared out any potential browser cookies that would be within the Chromium driver. So for that, we're actually going to go ahead and we're going to write a script that allows us to remove the cookies. So we want to do driver.manage and then delete all cookies. And the next line we're going to do is to actually have the web page that we're going to connect to open up in full screen mode. And for that to happen, we're going to go and actually use the window property, which is what I was writing before by mistake. And so this will allow us to go full screen. And now we need to pull in a web page. So we're going to get the get command. And what we're going to do is we're actually just going to pull in a web page from Amazon, which I just happen to have here. So I'm just going to go to the Amazon web page. And so I'm just going to copy the URL. Just need to copy HTTPS www.amazon.in or .com, wherever you're located. And so you can see that I've pulled in the Amazon web page, and then line 18 actually allows me to go and connect. So here we are, we have the Amazon web page that I'm pulling in. And then what I also want to do is I want to look for a specific ID in one of the elements. And so I have the driver, which is called find an element. And that allows me to look for any element that would be on the actual page. So here we have the HTML in the console screen, and I can actually then paste out an ID from the element that I want to use. So the find element is just the ID for each element, and most of them have them because they need it for JavaScript and CSS. So let's see, there's quite a few IDs, and we can select any of those. So what we have here is we have two-tab search text box, and then what that actually does is that finds the ID for the text box used for searching, and then we're going to use the send key command, which allows us to actually pre-fill in the search box, and we're going to use the test of Puma shoes. This is a fixed string, but you could actually put a variable in here if you wanted to pull strings from a database or an XML file. And then the next line on line 19 shows how long we're actually going to run the actual script for the search, which is only 10 seconds. And then once the 10 seconds has elapsed, we'll actually quit the script, which actually closes the web browser and takes us back into our screen here. And let's test that, make sure it's working. And everything's looking good. The web browser opens, which is what we expect. It goes to Amazon, fantastic. It now actually goes to the search screen and should fill in the Puma shoes. There we go, Puma shoes. And waits 10 seconds and it closes. And that's exactly what we were expecting. Now you can actually change the unit of time that you would have for the actual test. So if you wanted to see what was happening, so longer than 10 seconds, you can actually change the actual time or the actual metric. So in this instance, we got it as seconds and it's a unit of time, but you could do minutes or hours or microseconds. And you can change the keyword as well, so it could be jigsaws or anything that you wanted to check. But if you're actually building your own application, you want to be able to test your own data against your own application, that's where you put in that specific data. So let's look at the center, the heart of your DevOps environment, and that center is with Jenkins. So before Jenkins, developers would work on their code, and the code would then be checked into a source repository. You would then check for any issues, and then you would then send that code over to the operations team, and there would be a delay for actually delivering software. So the actual challenges developers had is that if they wanted to run any tests, they had to wait until their software was built, and there was a lot of problems in providing feedback, particularly if you had large teams working on software who actually had the error. The actual delivery of software was often delayed because of these key problems. So after Jenkins, what we actually have is the ability to be able to streamline this whole process. The build, test, and deploy happens continuously and are able to then notify developers and the actual specific developer of any errors that are detected, being able to speed up the delivery process much more efficiently. The focus of Jenkins is that it automates a continuous development, testing, and deployment environment. And it's open source. Jenkins is easy to install and configure. It's been around for many years now, and it is very mature. There are many plugins that you can use within Jenkins to be able to have the Jenkins product work with your environment. If there isn't a plugin, you can actually extend via You can actually write your own plugins if a plugin doesn't exist. So you can actually continue and extend and invest in the Jenkins ecosystem. And it can be easily distributed across multiple machines. So let's break out the architecture of Jenkins. So Jenkins starts as a remote source code repository, and it then pulls out the code every time there is a commit from into the server master. The server master will then have a slave that will run on either Windows, Linux, or Mac OS to be able to distribute its load across those environments. And after it's actually gone through and run its test, it'll then send out a report. The goal of the report is to communicate back to the team what has passed and what has failed the actual check-in process. Okay, so we're going to go ahead and show you how to install Jenkins on your local PC. So the first thing you want to do is check that you have Java installed. So we're just going to go into our system and see whether or not we have the Java JDK installed. You can do that by going into System Properties, Setting Advanced, and then Environment Settings. And there we are. We have Java JDK installed. And you want to just double check on the system variables to make sure that you have the Java_home installed correctly as well. And we have that installed. And under path, also make sure you have a link to the Java JDK as well. So we have everything installed. And what we're going to do is we're going to open up a command window and just do a double check right there. So open up command window and we're just going to check that we have Java installed. So we do Java-version and we have a version number that comes back. If we didn't have Java installed, we wouldn't get a Java version number come back. We'd actually have an error. So everything looks good. So the next thing we want to do is to go to the Jenkins website and download the files. So we're going to go to jenkins.io and that's the official Jenkins website. And if you want to download, you just go to jenkins.io/download, or you can just type into your search bar download Jenkins and that will give you a link straight to the download page. And one of the things that you'll see is that there's lots of different versions for Jenkins, because Jenkins runs on pretty much most operating systems, including Windows, Linux, and Mac OS. But we want to select the Windows version. So we've already gone ahead and downloaded a zip file which contains all of the files that we need for Jenkins. And so that's the zip file and we've expanded it. And what we want to do now is double click the installer file and we'll go ahead and install that. So we've already installed this. So one of the things that we'll get is a message asking if we want to repair. You would actually get a install message because it'd be a fresh install for you. But once you've done that, it has all the files and all the settings correctly installed onto your Windows computer. And we do all of our commands for Jenkins through a web page that's run locally on your PC. And so you're going to type in localhost:8080. And when you do that, they'll actually take you to Jenkins running locally on your PC. And here we have our Jenkins dashboard. And we've already gone in and created some sample jobs, and you can see those listed on the on the right-hand side of the screen. So let's go through some of the things you would want to set up here. So first of all, let's go into the Manage Jenkins screen, and that will actually, so we'll go to the Manage Jenkins tab on the left-hand side to do some standard configuration settings. So we'll go into the configuration systems, and if you want to, if you're like remotely connecting to a remote Jenkins environment, you can actually install a JDK remotely on that machine if you want to. We already have the JDK environment already set up, so yeah, that's good here. So we don't need to do that. But you'll also see as you go through the list of applications that you have: Gradle, Ant, Maven, Docker, Git, and other tools that you would use in a DevOps environment. There are many other tools you can install through plugins as well. Let's have a look at one more setting here with the security. The default security is Jenkins' own user database. That probably is not allowed within your company due to security restrictions. So you can choose LDAP, which allows you to connect with your Active Directory configuration. Again, because there are so many plugins for Jenkins, there are plugins for SAML authentication as well as OAuth. So let's go ahead and start a new build job. And so we'll select a new item, and we're going to select demo 1 from that to create a new item. And we're going to use just a freestyle project because I just want to demo how you can actually create a build. Select OK. Description, gosh, what could we write here? We can put in Slimpy demo. And we're not going to use source code for this one. We're going to do that in the next demo. But what we want to go down to is the job type. And we're going to build. We can just do add for execute Windows batch command. And so let's just put in a very simple command. And so we're going to type in echo, open quotes, hello world. And then we'll put in the timestamp. So we'll put in date first and then time as part of our output. Close quotes, and we're gonna save that. Also hit save, and that's our simple project. So what we want to do now is we want to actually go and select the build now command to actually run this project. Hit build now, and it'll take a couple of minutes for it to run. And here we are. This is our project, and we can actually now see the different builds that have happened. And if you look on the build history, you'll see the latest history shows when the build was executed. And if you click on that, you can actually start getting information such as the console output will actually provide information that we were asking for. So for instance, we have, first of all, we can see that the build was successful, and we see the output includes the hello all and date and time. So we're going to go ahead and create one more project where we can actually connect to a GitHub and use the Git command tool to be able to build a real project. So we're going to go ahead and create a new item, and we're going to call this one Jenkins. It's a freestyle project, and our description is demo using Git. So we're actually going to connect to GitHub. So to do that, we're going to go into source code management tab, and we're going to select Git. And so we select that, we can actually now connect to GitHub. So to do that, you go to your GitHub account, and you want to go in and select the clone or download, and you get the URL link from there. So copy that, go back to Jenkins and add that in the repository URL. So you paste that in, and then for credentials, we want to add in our Jenkins credentials. And so just make sure you have those selected correctly, and we've select add, and then we just pull those from the drop down. And let's not change any of the other settings. And then for the build, we're actually going to be building a Java application. So it's a slightly different set of build commands. So we want to type in javac for compile, and then space, and the file name is simply.java, and then you want to put java and space simply on a new line. Save that. Again, this is a really simple application, but it gives you the understanding of what you need to do here. And so we saved it, and let's now go ahead and see if everything's working. We'll do the build now and see what happens. And here is our first build. We select that. We can go to the console output for details, and what we can actually see if we scroll down is that the finished output at the very end says success, which means everything was built correctly. And so that's how you're able to connect Jenkins with a Git repository. And the thing that's great with working with Jenkins is that it connects to so many different systems and really does become the central point of your DevOps toolset. So let's start looking at the operations side of the DevOps environment, and let's focus in on Docker. So before Docker, the problem you had as a developer, if you're working on a virtual machine, the actual virtual machine was your VM, was a very complex piece of software. So first of all, VMs have not been around for very long. We're talking about less than 10 years. And the typical way of having a VM is that it's very heavy on usage on your computer. You essentially are running everything of the VM plus the tools to run the VM on your computer. With Docker, what you're able to control is the actual development environment you're working in. You don't have to be encumbered by all of the additional extraneous processing that a VM environment has. You're really stripped down to just the bare minimum that you need to have to run the environment using a containerized solution known as Docker. So Docker is essentially an OS level virtualization software. It is a maturity of the solutions that were started with virtual environments, and there are other solutions out there. Docker has become the de facto container solution that you can use for building out and guaranteeing that what the developer is building is going to be the same as what the operations team will use. So Docker itself is highly scalable and efficient. You can have many Docker environments running on a single piece of hardware. The boot up time is incredibly short. You can reuse the data volumes very, very easily. It's not complicated. And the actual applications are completely isolated. This is like a perfect sandbox environment. So let's dig through the architecture of Docker. So there are really two parts to Docker. There's the Docker engine and there's the Docker client. The Docker engine is comprised of the Docker CLI, which connects with the server daemon. The Docker client will then issue the commands to the Docker daemon. And then the Docker daemon will then interact with your system to be able to provide the tasks and tools needed for you to be able to build out your solution. The actual images that Docker uses are instructions for creating Docker containers. And the actual Docker container itself is a lightweight package that contains all the dependencies needed to run an application. Now, once you have created a container that is of value to your team, you want to be able to store that container so that other team members can use it. And this is where you would use a Docker registry to be able to host and distribute multiple Docker images. So in this video, we're going to go ahead and see how we can get Docker installed and running. So we're going to go ahead and open up our terminal window, and we want to validate whether or not Docker is installed. If you haven't installed Docker, you can actually go ahead and use the following command, and that is to enter in sudo apt install docker, and that will go ahead and run the command to install Docker. I already have Docker installed on my system, so I'm not going to do that right now, so I'm just going to delete that out. But what I am going to do is check to see what Docker images I have installed on my system. And to do that, I'm going to type in sudo docker images. And when I run this will actually show how many images I have. And right now I don't have any images at all. So why don't we go ahead and install an image. There are two ways you can create an image for your Docker environment. One is to get one from Docker Hub, and the other is to create your own image. Let's go ahead and get one from Docker Hub. And so the command line that we'd want to write is sudo docker pull redis colon, and after the colon we're going to actually write the name of the actual file that we're going to be connecting to from Docker. So I'm going to go ahead and go to Docker Hub, and I've already logged in with my user ID and account. So I'm going to go to Docker Hub, and hub.docker.com is the website address, and I'm already logged in with my Simplilearn account. And what you can actually see is different repositories that I have already created below. I'm going to click the Explore button, and I can see the Redis image, and these are all the different commands that I can actually use, all the different variations that I can create. So I can do 5.0, I can do a 32-bit version, I can do a 4.0 version or a 3.8 version, or if I select latest, that will allow me to just pull the latest version even if it's updated. So I'm going to go back to my command line and do latest, and what's going to happen now is that we're actually going to pull the files live over the internet and create the Docker image. So this is going to take just a few minutes. Of course, if your internet speed is faster, then this will happen a lot faster. And here we are. We have everything downloaded, which is great. And so let's just go and check and see if the image has been added to Docker. So we do sudo docker images, and now you can actually see that we have the latest Redis image, and it's given the default image ID, and there's the size of the Docker image, and the tag is latest, so it's the latest version of Redis. And I'm just checking to see if there's any other images running, and no, there isn't. So let's go ahead and now create a container. And so the command for that is sudo docker run -d -p 0.0.0. I think it's .80:80 space redis latest. And let's run that. Got an error message. Okay, now you know that it's a real demo. This is really live. So I'm just going to clear the screen, and let's write that in again. So sudo docker run -d -p, and it's 0.0.0.0:8080 latest, and there we are. Everything's up and running. Awesome. So let's just go ahead and check that we actually have the image running in Docker. So sudo docker ps, and there you can see that we actually have the latest Redis version, and it was created 16 seconds ago. We have a new container ID for it, and there's our port that we've created. And let's see if we can view all the running containers, and sudo docker ps-a, and there we are. And we created that container 42 seconds ago. But one of the things you'll notice is the name for the Docker is created automatically by Docker. And here we have Stupefied Engelbarts is the name. Let's change that name to something that's more meaningful for the work that we're doing. So that's actually fairly easy to do, and it's going to be our final task here. So we're going to type sudo docker, and the command is rename, and we want to copy over the old name, and then we put in the old name, and then you do a space, and then you put in what you want the new name to be, in which case we're going to make it Simplilearn. We run that command. That's good. Now let's validate that everything has been changed. So we're going to do sudo docker ps-a, just ps. And there we are. Everything has been renamed. And that gets you started working with Docker. Now let's move on to Ansible. So before Ansible, the ability to be able to deploy software across a network was pretty hard. You couldn't guarantee that your web servers were all consistent and that the database environments were consistent. This was okay if you had a small environment, but once you actually start getting into more complex environments, it became very difficult to manage. Ansible is code that allows you to be able to consistently and reliably create and stand up the environments that you need to be able to store your code for production. So whether or not you require one server environment or you need 1,000 server environments, using tools like Ansible will allow you to be able to consistently deploy out environments that all look the same. So essentially, Ansible is a configuration management tool, and it allows you to be able to deploy automatically to a large variety of environments. The actual tool itself is a push-based configuration tool. It is an agentless tool, so there is no communication coming back about the health of the environment. We actually have tools that we'll cover later on in the video that cover that. Ansible does have a consistency of its product performance, so you know that if you're using Ansible that it's going to work. It's just a very consistent product, and it uses SSH for very secure connections. So it doesn't matter whether or not you have 1 or 1,000 pieces of hardware you're looking to configure, you can actually be rest assured that there will be no security infringement because of the use of SSH. And we look into the architecture of Ansible. It's a very simple architecture. There is the Ansible management node that has playbooks which contain the instructions that you would have for your environment, and that playbook is then pushed out to all the different nodes that contain the hardware that you wish to configure. The actual module collection is the configuration code itself. The playbooks are the instructions of that configuration, and then the inventory is the document of the different groups and the hardware within those groups that you would be pushing out to. So we're going to go ahead and install Ansible onto the system here, and we're actually running our environment in a Linux environment right now. So we have a master environment and a standard node, but we're actually going to go into our terminal window and we're going to do everything on the master node. So the first steps we want to do is actually go ahead and install Ansible, and we're going to do that by installing sudo yum install ansible -y. And this goes ahead and downloads all the files that we need and starts to run the installation. And let's go ahead and see if it's installed correctly. So we're going to type in vi-etc/ansible/hosts, and there we see we actually have a default